Okay, welcome to another video on manipulating indices. This is part 2 of my video series on manipulating indices. Now, as I always like to do, I've put some practice questions for you that is based on part 1 of this series. So take about 3 or 4 minutes, have a go at the questions that you see in front of you and see if you can get the right answers. Okay, so let's go through the answers very quickly. Now, minus 9 times minus 9 is plus 81. Remember, if you take any number and square it, or to the power of 2, it is always positive. Now, our next one, you should know this off by heart. You will get the answer of, well, let's think, 12 times 12 is 144, 13 times 13 is 169, so 14 times 14 is 196. Again, if you're not sure about that, you should be remembering those off by heart for your GCSE or iGCSE exams. Okay, 3 to the power of 4, well, that will be 81. 2 to the power of 6, well, again, if you work through timesing by 2 each time, you can work this out. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is our answer of 64. Excellent. And for the next one, 7 cubed, well, 7 times 7 is 49, 49 times 7 is 343. Okay, now for our indices with a fraction, remember a fraction means a root of some kind. So always remember, if there's a fraction in the power, it means some kind of root. Now, because we have a 2 in the bottom, we are going to do the square root of 64, and the square root of 64 is 8. Though strictly speaking, it should be plus or minus 8. Again, if you're not sure why it should be, then have a look at my video on quadratic equations. It will make a bit more sense then. Okay, in the same way, 64 to the power of 1/3 will be the cube root of 64. So it's the cube root, not the square root, and that will be 4. If you're not sure, you can always check. 4 times 4 is 16, 16 times 4 is 64. Now, luckily for question H, we can use what we did in question D. Now, it says here 2 to the power of 6 is 64. So if we take the 6th root of 64, we'll come back to our original answer of 2. So sometimes that will save us time. If we have an answer already from a previous question, we work backwards, we can then find the next answer. Now, for question I, 125 to the power of 1/3. Again, that's a cube root of 125, and that will be equal to 5. And then in our last question, this will be the square root of 10,000. Too many zeros. And that gives us 100, because 100 times 100 gets us back to 10,000. Now, if you found those questions straightforward, that's great. Let's move on to more fractional indices and then negative indices. If, however, you found that a little bit difficult, then go back to manipulating indices part 1, where I will go through those kind of questions in more detail. Now, so far we've only looked at fractional indices where we have a unit fraction. You probably are thinking, what is a unit fraction? Well, it's a fraction where it has 1 in the top, that is 1 in the numerator. So a quarter would be a unit fraction, or 1/7 would be a unit fraction. Any fraction with a 1 in the numerator, or 1 in the top of the fraction. Now, we have to be slightly more careful when we look at a question which is not a unit fraction. So let's look at our first example. Now 27 to the power of a third, well, that is equal to the cube root of 27, which is 3, just like in our previous slide. Now the way we work out one without a unit fraction is we separate it out. What do I mean by this? Well, we write 27, our base number doesn't change. We write it as a unit fraction. So instead of writing 2/3, we write 1/3, and then we put the 2 outside of the initial calculation, like so. Now we're going to use our first answer. 27 to the power of a third is 3. So we substitute 3 for the bracket. So we put 3, but don't forget to put the squared outside. Of course, we all know 3 squared is 9. Okay, we're going to do the next question in the same way. So 64 to the power of 1/3. We did this in part G of the last slide. That will be equal to 4. So if you're not sure where that comes from, look at part G in the starter. Now for this part, we separate out. So 64 stays the same. We have 1/3 as our power, and then we bring this 2 and put it outside. We know what 64 to the power of a third is, that is 4. So we substitute 4 in for this thing here. Then we get 4 squared is equal to 16. Now we don't always have to square right at the end. It does depend on the question. So for my next part, 81 to the power of a quarter is the same as the 4th root of 81. And it might take you a little while to think it through. Again, all these answers are whole numbers and they're done on purpose, particularly in the IGCSE exam, and that will give us 3, because 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. And again, we're going to use this answer of 3 in our next calculations. So here again we separate out the unit fraction from the 2 and the 3 in this case. So we will do 81 to the power of a quarter squared. Likewise here we do 81 to the power of a quarter cubed. Why cubed? Because we have a 3 in the numerator here. Now we know what 81 to the power of a quarter is. We've just worked that out, it's 3. So here we do 3 squared. In this case we do 3 cubed, because we have a 3 here. And that gives us the answers of 9, and here the answer of 27, like so. Excellent. So have a go at the next question. I will give you a hint, however. 32 to the power of 1/5, that's the 5th root of 32. Again, these answers generally are whole numbers. You won't get any tricks with fractions or decimals or anything like that. And I can tell you the answer here is 2, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and finally 16 times 2 is 32. So, see, using the technique I've shown you to work out 32 to the power of 2/5, 32 to the power of 3/5, and then finally 32 to the power of 4/5. Okay, take 1 minute, see if you can answer the questions below. Okay, hopefully you got 4, 8, and then finally 16. And it's all about that number in the numerator here, like so. Now, just for a quick summary of what we've done. So I've given you a handy review here. So 125, for example, to the power of 2/3 is done the following way. You take the root using the bottom number, and then you do the power to the top. So if you need some review notes on what to do with more complicated fractional indices, then I put that extra slide in there for you, just to help build your understanding of what is going on with these fractional powers, these fractional indices. Okay, so now it's your turn. Have a go at these 5 questions here. Again, always approach it in exactly the same way. You should take about 5 minutes to do these particular questions. Okay, so this is 25. Excellent if you got that. Here, this will be 100. Here, well, this will be 2 to the power of 3, which would be 8. Here, this is the square root of 9, which is 3. 3 cubed is 27. So in this case, because our index, because our power is a fraction more than 1, 3/2, your actual answer will be bigger than the initial number. And that's absolutely normal. Likewise, this will be 81. Okay, really well done if you got those questions. These are getting more and more tricky as we go along. Now, if you'd like some extra practice, I've put another slide for you like so. So again, if you would like to move on to the next part of the video, by all means. If you'd just like some further practice, then have a go at these questions in the same way. Okay, so this will be 8, because the square root of 4 is 2, 2 cubed is 8. This one will be 9, the cube root of 27 is 3, 3 squared is 9. This one will be 125. The square root of 25 is 5, 5 cubed is 125. Here, the square root of 9 is 3, and then we have to do 3 to the power of 5, which takes a little bit more calculation. So 3 squared is 9, 9 times 3 is 27, 27 times 3 is 81, and then finally 81 times 3 is 243. So that takes a little bit more mental calculation. And our last question, square root of 36 is 6, and then we have to do 6 cubed. Well, 6 cubed is 6 times 6, which is 36, and then 36 times 6, which, if I'm not mistaken, again, if you're not sure how to do this, you can always use normal multiplication methods. 6 carried 3, 6 times 3 is 18, 18 times 3 is 21, so our answer is 216. Don't be afraid if you find it difficult to work out cubes or to the power of 4, then just do what I did here. Just do some basic multiplication so that you can work out what the answer is. Don't be afraid to do everything in your head. You don't have to. Okay, so let's move on to the final part before we combine everything together, and that is what's called negative powers. Now, the way I like to teach this is to look for patterns. As humans, we often can recognize patterns very quickly, and rather than always go into the algebraic nature of these questions, if we can see a pattern, we are much more likely to have that easily understood in our brains. So let's use some results that we've looked at already. 3 to the power of 4 is 81. 3 cubed, or 3 to the power of 3, is 27, and 3 squared is 9. We've looked at all of these in the past few slides. Now, 3 to the power of 1 is simply 3 on its own. Remember, you can write 3 as 3 itself, or 3 to the power of 1. So, take 10 seconds. What's the connection between 81, 27, 9 and 3? Okay, hopefully you've noticed this is actually a geometric series, as in each time you remove a power, we are dividing by 3 each time. And this then helps us to work out what these negative indices are. Well, if we keep dividing by 3, 3 divided by 3 is 1. And that fits in with the rule I talked about in part 1, where anything to the power of 0 is 1. You probably remember my favourite football team, Derby County. 2 to the power of 0 is 1. A smiley face. 2 to the power of 0 is 1. Anything to the power of 0 is 1. And that's important to remember. Now we keep using our pattern. We keep dividing by 3. So 3 to the power of minus 1 is the same as 1 over 3, 1/3. So that's our key thing that we have discovered, that any negative index can be written as a fraction. And that's a very important point that we'll use time and time again. Our next one, well, what is a third divided by 3? That is, if you have a third of pizza and you divide that third into thirds, you will get 1 over 9. And if you don't believe me, you can check that on a calculator. 1/3 divided by 3 is 1 over 9. Likewise, we divide by 3 again, and 1/9 divided by 3 is 1 over 27, like so. Okay, so that's the way we work it out. We just keep dividing by 3 each time. Let me do the 5s with you as well. So we're dividing this time, each time, by 5. That makes sense because our base number is 5. So 25 divided by 5, well, that will be 5. That makes sense with the answer we got previously with 3. 5 divided by 5. Again, that fits into my Derby County rule, as I like to call it. 5 to the power of 0 is 1. And likewise, 1 divided by 5 is 1 over 5. See if you can work out the last two in the sequence for me. I'll give you 10 seconds. Okay, so you should have got 1 over 25 and then finally 1 over 125. Notice, however, you could also write this fraction here as 1 over 5 squared. Likewise, you could write this fraction as 1 over 5 cubed. So I'll give you another 10 seconds. Can you see the link between our original power and the answers I've just written? Okay, hopefully you've noticed that 5 to the minus 2 is the same as 1 over 5 to the positive version of this. And likewise, 5 to the minus 3 is the same as 1 over 5 to the positive version of the index there. So that's a really nice and easy way of remembering how to work out these negative indices. So, using what we've just done, see if you can work out now for the powers of 2 what the different answers are. I'll even start you off, because I'm a nice person, that this here is 60. Okay, so you should have got 8, I think that's straightforward, 4, 2, remember anything to the power of 0 is 1. I'll keep talking about that again and again. This one here is 1 over 2, this is 1 over 4, which can be written as 1 over 2 squared, and then likewise this can be written as 1 over 8, which is then the same as 1 over 2 cubed, like so. And again, like the previous couple of slides, I have given you a quick note for you as well, just to help your revision, that if you have something like 4 to the minus 3, that minus tells you it's 1 over. So in this example, you simply write this as 1 over 4 to the positive version of this, which is 3, and again that would be equal to 1 over 64. If you're a big fan of algebra, and I know a lot of you out there are, you can consider the rule like this: x to the minus n is the same as 1 over x to the positive n. Okay, let's just quickly do some practice questions just to reinforce what we've done so far. So let's have a look at this. So 2 to the minus 3, using the rule we've just seen, we can write as a 1 over the positive version of this, that is 2 cubed. And remember, 2 cubed is the same as 2 times 2 times 2, and that is equal to 8. Our next question, we have a negative index, so again we write that as 1 over the positive version, 10 to the power of 4, and that's equal to 10 times 10 times 10 times 10, so that's quite a few zeros. That will be then 10,000. Make sure we have 1, 2, 3, 4 zeros. Okay, have a go at the last 3 questions in the same way and see if you can get the right answer. Okay, so we should have got 1 over 6 squared. That's equal to 1 over 36. And the nice part about the last 2 questions, well, this is 1 over 8. Ooh, it goes 8. 8 to the power of 1, and 8 to the power of 1 is simply itself. So we get 1 over 8, and likewise here, we get 1 over 3 to the power of 1, which is itself, so 1 over 3. Okay, so again, if you'd like to do some more practice questions on this, have a go at these questions here. I will just do question D for you, which is a little bit different because we have a fraction. Now, if we have a fraction that we're finding a negative power, what we do here is we flip the fraction. So we take our fraction, we do 5 over 1, and then we change the power to a positive. That means then we do the positive power to both of parts of the fraction. So we get 5 to the power of 1 over 1 to the power of 1, lots of ones. 5 to the power of 1 is 5. 1 to the power of 1 is 1. And then this is equal to 5. So, have a go at those questions and just make sure you're really happy with working with negative powers. Okay, so this is 1 over 4. This is 1 over 10. And if you've listened to me go on and on about this, you should know that is 1. This one is a little bit more tricky. Remember, if we have a fraction, we are doing a negative index 2. We flip the fraction, 4 over 3, and change this to a positive. Then we do the power to the numerator and the denominator, the top and bottom of the fraction. And then we get 16 over 9, and I will leave my answer as this. You could, if you wanted to, convert that into a mixed number. Okay, and this is where it gets the most difficult out of everything we've done so far, is when we combine negative indices on one hand with fractional indices on the other. Now, the thing to remember with this is to deal with the negative first and then work with the fractional power afterwards. So we deal with the negative, we get the negative out the way, and then we can do the normal fractional power calculations. What does this mean in practice? Well, let's have a look at these questions here. So, 25 to the minus a half. The first thing we do is we deal with the negative. We write it as 1 over the positive version of this, which is 25 to the power of a half. Now we apply what we did in the start of this video, which is the 25 to the power of a half, or that can be written as a square root, like so, and the square root of 25, or that will be 5, like so. Okay, let's do the next question in the same way. So what's the first thing we do? We change it into the positive version by writing it as a fraction. 1 over 27 to the positive 2/3, like so. Now we have to use what we did a few slides ago, which is we separate out the unit fraction from the numerator. What does that mean in normal English? Well, that means we write 27 to the power of a third. There's our unit fraction with a 1 in the top, and then we pop the 2 outside. Now 27 to the power of a third, well, that's the cube root of 27, and don't forget we have that squared outside the cube root. The cube root of 27, well, that is 3, because 3 times 3 times 3 is 27. Don't forget that 2, and now we can include the 2 in. 3 squared is 1/9. And we are done. So even on the surface, it looks like a straightforward question. There are quite a few steps to work through. If you're not sure about any of those steps I've just done, look through part 1 and the early part of part 2 on this video just to make sure you're clear on what's going on. Okay, now finally we've got some tricky questions here. Again, we deal with the negative first. That means we flip the fraction. So 64 goes on top, 1 goes below, and then we take the positive version of minus 1/3, which is 1/3, naturally. Then we take 64 to the power of a third over 1 to the power of a third. Well, remember, 64 to the power of a third is the same as the cube root of 64. Like what we did in the starter, that is equal to 4. Any power, sorry, I should say this a bit more accurately, 1 to the power of anything is 1, and so 4 over 1 is 4, and we're done. Okay, have a go at the last question in the same way I did question C. Okay, so first of all, remembered well, we have to flip the fraction. So we've got 16 on top, 9 below, like so, and then to the power of positive a half. Then we apply the half to the numerator and the denominator. So we have 16 to the half over 9 to the half. Then we remember from earlier that to the power of a half is a square root. So we square root 16 and we square root 9. Square root of 16 is 4. The square root of 9 is 3. And we're done. Okay, so if you look at the success criteria on the left-hand side, we have now started to achieve, I will use index laws to calculate negative powers. That's what we did earlier. And what we've just done now are negative fractional powers. Certainly grade A at GCSE or iGCSE. If you're doing the new GCSE, then we're talking grade 7, grade 8. Okay, so in order to help your revision, I've put a summary of all the rules that we've looked at over the last 2 videos. So if you need a summary sheet or a summary document of the rules we've looked at, feel free to take a screenshot of that to help you in your revision. So the final one that we did there is part 7 and part 8. Now, before I finish the video for today, I would like to do some iGCSE practice questions. Once you've understood a topic, or you thought you've understood a topic, the ideal thing you can do is find a past paper from the course that you're doing. My school is looking at iGCSE Cambridge 0607 course. However, if you're doing Edexcel or AQA or OCR or even the middle years program, then you should look at the papers or coursework that you would be expected to do. Because a key technique when you're working towards exams is getting used to the style of the particular paper. So I will concentrate on iGCSE Cambridge, but you'll want to access your own exam past papers. Okay, so I've taken a couple of questions from the paper 2 from the last couple of years on iGCSE Cambridge. I've just noticed a spelling mistake. That is going to annoy me. So we've got question 8 and question 12. You have 5 minutes to do this, as we have 5 marks. Again, time yourself accurately for 5 minutes. Have a go at the questions you see in front of you. The question 12, if you cannot see, says 16 to the power of 3/4, like so. Have a go now. Okay, hopefully you've given yourself the full 5 minutes and checked your work carefully afterwards if you finished quickly. Now for our first question, we take the numbers separately. So 8 divided by 2 is equal to 4. Now we look at the indices. Y to the power of 8 divided by y to the power of 2. Remember, when we're dividing with indices, we minus the small numbers, so we get y to the power of 6, and then we combine this with this answer here. So we get 4y to the power of 6. I think they're being quite generous, giving you 2 marks for that question. For part B, we separate out the number from the power, so we do 2 to the power of 5 times w squared to the power of 5. Now we've worked a lot with indices in this video. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. That is equal to 32. And remember our third index law from part 1, w squared to the power of 5, that's 2 times 5, so that gives us w to the power of 10. So the answer is 32 to the w to the power of 10, like so. Okay, in our second question, find the value of 16 to the power of 3/4. Again, we approach it in the way we've done our previous examples. So we write the question, 16 to the 3/4, and we separate out the unit fraction from the number at the top. That means, in practice, 16 to the 1/4, and then we pop the 3 outside like so. Now 16 to the power of 1/4 is the 4th root of 16. Don't forget the cubed outside. Now the 4th root of 16 will be 2, because 2 times 2 times 2 times 2 is 16. So you're timesing 2 4 times. And then we pop the cubes afterwards, don't forget that, and then 2 cubed is 8. So our answer for that question is 8. If you got 5 out of 5 on that, then I feel you're ready then to do manipulating indices for the iGCSE Cambridge or Edexcel exams. Well done. If you didn't get those correct, then do look carefully through part 1 and part 2 to make sure you really understand this, sometimes I think underestimated topic. Okay, well thank you for listening to the video. Again, if you haven't subscribed, please subscribe. Please tell all your friends, all your family about the lovely maths that we're doing on here as well. And I wish you a very happy day. Okay, bye-bye.